Recording is rolling. It is Thursday, February 19th. Today and tomorrow are both good Alex days. You guys can work on this Alex assignment, 9394. That's a single assignment due tomorrow. Once you finish that, remember too, your 70% pi goal is due March 11th. That's about 3 weeks from now. So beginning of class, I'll do some review questions with you guys. Review. Right, so both of these sections, 9.3 and 9.4, so questions to see off the Alex assignment, are related to graphs and graphing. Right, so let's look at graphs and finding asymptotes is a big part. Right, there are three kinds of asymptotes you've seen. You've seen vertical, horizontal, and oblique asymptotes or slant asymptotes. So let's do some review. But you see this, h of x is, let's call it 50x over x squared plus 7. Right? And I'm going to say, okay, what does this graph look like? Okay, no, it could make an XY table, X, Y, right? And punch in values for X and just pop them in and see what I get for Y. Okay? But what could help frame this too is, do I have any horizontal or vertical asymptotes? Now, vertical asymptote, you normally get by setting the denominator equal to 0. So say, okay, x squared plus 7 is equal to 0. X squared could be -7, or it can't factor it, or take the square root of negative. Right, so there is no vertical asymptote. Okay, so if I were to eventually graph this, okay, the denominator will never be 0 because this expression never zeroes out. Okay, so there's no vertical asymptote. Now, horizontal asymptote, horizontal asymptote. Okay. Now, the rules, well, let's see what could pertain to this. Okay. It's like if you let x become a big number like a million, where does this graph eventually approach? Okay. Now, whenever the power on x is, like the degree of x is larger on the denominator than the numerator, here I have a degree of 2 at the bottom, degree of 1 in the numerator. Okay. That means this denominator is going to grow much, much faster than the numerator. Right? So if you plug in a million for x, okay, the denominator is going to dominate, and you get 1 over a large number, and this always goes to y equals 0. So, okay, so far from the asymptotes, I know this. I know x-axis, y-axis. Okay. I know down here at y equals 0, which is the x-axis, there is a horizontal asymptote. That's as much as I know. I know there's no vertical asymptote. Okay? And then I can plug it in a bunch of points and see what happens. Right. Now, I've plugged this in ahead of time and Desmos to show you guys. Right, so, yep, there's the function right there, exactly as I wrote it on the paper. Yep, there it is, same thing. Right, let's see, what graph did Desmos come up with? Yeah, right. Now, again, we could plug in a bunch of points, but I definitely see no vertical asymptote, and there's a horizontal asymptote at y equals 0, the x-axis. Yep, it's all there, all there. All the parts are there. All right, let's try a couple more examples. Okay. So next one I want to do with you guys, let's say f of x is, right, let's again do a fraction because you guys are, for both these lessons, 9394, you guys are graphing these ratios of polynomials. So 5x squared plus 2x plus 13 all over x squared minus 9. If you see something like that, what should you do? Right? Well, remember the last point I said, well, I can find the vertical asymptotes by usually saying the denominator equals 0. So vertical asymptote at, I'll let x squared minus 9 go to 0. Now, the exception to this rule is if you also factor the numerator and some part cancels out, you would have a discontinuity or a hole there, but not necessarily a vertical asymptote. But I don't think I can really factor that numerator, so I don't have to worry about that. Now, this denominator actually can factor. This is x plus 3, x minus 3. Okay, which means that if x is -3 from here or +3 from here, that would either zero this out. We would zero out the whole thing either way. So vertical asymptote at x equals -3 from this one, and also x equals +3 from this one. Okay, so we get two vertical asymptotes. Okay, now that's not the end of the story. Let's do horizontal asymptote. Okay, so what's the rule here? Now here I see the degrees on top and bottom match. I got an x squared up here and an x squared down here. There's a plus all this little piddly stuff. Again, the thought process is, what if you let x go to like a million? Now, if x is going to a million, all these other little terms, the 2x of 13 and that minus 9, they become negligible and overall irrelevant. I mean, they're still there. They change things a tiny bit, but hardly anything. What's going to dominate are these terms right here, right? The 5x squared versus the x squared. And again, if you plug in like a million, you get like 5 trillion over 1 trillion. It's really this ratio right here. Right? So this is going to approach y equals 5. Right? And there's more mathematical proper ways to do that, which I've done the longer videos with you guys, but that's kind of the shortcut of it, right? So if the degrees match, so in this case, x squared, you take the ratio of the coefficients, 5 to 1, and in the long run, if x becomes very big, positive, or you could go to negative infinity for that matter. You could go the limit the other way. Okay? Actually, here's kind of the proper mathematical way to do this is to do it f of x equals, I'm allowed to divide each of these 5 terms by, let's say, x squared. That'll give me 5x squared over x squared is just 5. 2x over x squared is 2 over x. And this is 13 over x squared. Okay. Then in the denominator, x squared over x squared is 1, and then minus 9 over x squared. Okay. Okay, so that's this and this are the same thing. Okay, but I'm going to introduce a limit. Limit x approaches infinity. You can also do negative infinity. Okay. But if I do that, what's 2 over infinity? Like if I buy 2 lottery tickets, what's my chance of winning? Well, approximately 0. Okay, so 0, 0, 0. What am I left with? 5 over 1, which is this. All right, there's a little mathematical. Okay, show that. All right, and then again, I plug this into Desmos. All right, so there's exactly the function I wrote on paper. Okay, and here's the graph. Zoom out. Yeah, I definitely see vertical asymptotes at x equals -3 and x equals +3. Okay, and also a horizontal asymptote at y equals 5. Yeah, it's all there. All the parts are there. Yeah, just like I showed you. So it's all shown up. It's all shown up. Right. So let's do one more example. I want to fit in one that has an oblique asymptote because that was a weird one you guys saw the first time yesterday. Let's call this g of x. Again, set up a fraction. I'm going to go 3x to the 4 plus x squared plus 8. And then denominator, let's go 2x cubed plus 5. Okay. Okay, so the vertical asymptote would happen where this denominator, 2x cubed plus 5, goes to 0. So subtract 5 from both sides, divide by 2, take the cube root. Okay, so there's going to be a vertical asymptote that opens up. But I'm more interested in the oblique asymptote. Okay. Also called slant asymptote. Okay. And Aleks was also using that term. Right. So if you see slant asymptote, so kind of okay. Now, why do I think there's a slant asymptote with this one at all? Okay. And it has to do with, again, looking at the degrees of x at the top and bottom, right? So the highest power of x. Okay. Okay, x to the 4 here versus x to the 3 here. You see how the difference between these two is 1? Okay. So in the long run, like if you let x go to 1 million, and all these other terms become like negligibly small, effectively. Okay? Okay, and these terms are going to dominate. Okay, so 3x to the 4 compared to 2x to the 3. Well, if you divide that out, this works out like something to do with x. Oh, and I know y equals x is like a linear relationship. Okay? Okay. So the proper way to get the slant asymptote is to use long division. Long division. So I'm going to take, I'll show you guys how to set it up. 3x to the 4 plus x squared plus 8. Okay. And then outside I do 2x cubed plus 5. Okay. And I start doing that long division process. Now I did a few of these with you guys already yesterday, so I'm just reminding you guys the big picture process. Okay. Okay. And you'll get some form y equals mx plus b. In fact, I bet the slope is going to be 3 over 2, but there will also be a plus b term. Okay. So see your notes from yesterday if you want to see some examples of that. But what does this look like on the graph? Right, so here's Desmos. I typed in to see, does that match that? Yeah, that's the same function. And what does this graph look like? Zoom out. Yes, I have that vertical asymptote, which I said there was going to be one. I didn't finish this process, but if I did, I could get x equals whatever that vertical asymptote is. Right? Okay. And also, again, because the degrees are off by 1, and it's 1 more than the top, right? 4 versus 3. I know if I do long division, I will get a linear outcome, which is going to represent the slant asymptote. I see it right there. You guys see this oblique asymptote right here? All right, so there you go. There is a quick rundown of the Aleks puzzles that you guys are going to be seeing. Okay, so I'll be walking around class helping you guys out. Okay, and you can be working on those Aleks assignments right there.